you go for the next part of the discussion in this valence bond theory, now we'll go for types of overlapping. In these types of overlapping, first one is SS overlap. SS overlap. In this SS overlap, if you take example, as already I told you, it is H2 molecule. In this H2 molecule, the electronic configuration, we take one hydrogen in that H2 molecule, the atomic number of hydrogen is 1, and if you write the electronic configuration of each hydrogen, the electronic configuration is 1s1, and in this 1s1 atomic orbital of hydrogen, 1s atomic orbital is spherical in shape and it contains one unpaired electron. The shape of any s orbital, not only one s orbital, any s orbital shape is spherical in shape. So therefore, because it contains two hydrogen atoms, take two spherically shaped s orbitals, that is s atomic orbital of hydrogen. First s atomic orbital of hydrogen and second s atomic orbital of hydrogen, second s atomic orbital of hydrogen, or else you can just take two spherical shaped structures of hydrogen and place one electron over here and place one electron over here. Both are spherically shaped. First 1s orbital of hydrogen and second 1s orbital of hydrogen. Both of them, they are trying to overlap. When they are overlapping, you find that both the electrons in the 1s atomic orbital, they mutually share against each other, equally they share. When they share equally, it will result in the formation of a bond pair, that is first hydrogen and second hydrogen. They equally share, first hydrogen and second hydrogen atom, they are 1s orbitals, they share equally, 1s and 1s, they share equally. This is the bond pair, and this will result in the formation of the sigma cloud. This is before overlapping, during overlapping, after overlapping. You find that this is a sigma cloud. You can see this is nothing but a sigma cloud. Finally, a sigma bond is obtained between the two hydrogen atoms. Here we have one hydrogen atom and here we have one hydrogen atom. A sigma cloud is obtained, and that will finally result in the formation of one sigma bond between the two hydrogen atoms. One thing what we have to understand here is, during the s orbital to s orbital overlapping of the two hydrogen atoms, s atomic orbital spherical in shape of the first hydrogen atom, s atomic orbital of the second hydrogen atom, which is spherical in shape. The sigma bond which is formed because of the overlapping of both the s atomic orbitals of hydrogen, the sigma bond which is formed in this kind of overlapping is non-directional. The sigma bond obtained in this overlapping is non-directional because, as already I told you, the s atomic orbital which is spherical in shape, it has uniform plane of symmetry, that is the electron cloud density is uniform in all directions, so you cannot differentiate the electron cloud into a particular axis or into a particular direction. Because the electron density in the spherical shape of the s atomic orbital is uniform, the sigma cloud or the sigma bond which is formed between the two atoms in this overlapping also, it is non-directional. So that's why this is a special type of overlapping, and the sigma bond which is formed is very strong bond. So first type of overlapping is completed. Go for second type of overlapping, sp overlapping. Sp overlapping. If you go for sp overlap example, the best example of sp overlap is HCl molecule. In this HCl molecule, you are able to find two atoms, one hydrogen and one chlorine. Hydrogen atomic number is 1 and chlorine atomic number is 17. So if you take hydrogen, atomic number is 1, write the electronic configuration 1s1. So it has 1s atomic orbital and 1 electron. And if you go for chlorine, 17, you can write the nearest noble gas configuration, neon of 3s2, 3p, 3p5, but this 3p5 atomic orbital of chlorine, it can be resolved, okay, because it is a degenerate orbital. 3p sublevel is degenerate orbital. It has 3 degenerate orbitals. This 3p5 of chlorine, this 3p5 of chlorine, this 3p5, you can show it in the form of, that is 3px2, 3py2 and 3pz1. We can see that in 3pz atomic orbital, we have one unpaired electron. So, and moreover, any p atomic orbital of a given element, it is always dumbbell shape, and any s orbital of a given element is always spherical in shape. So therefore, what I am doing here is take the spherical shaped structure of hydrogen with its electron, and which belongs to, this orbital is 1s orbital, 1s atomic orbital of hydrogen with its unpaired electron, and take 3pz atomic orbital of chlorine, which is dumbbell shape. So this dumbbell shape of the structure of the chlorine, which it has one electron, chlorine, its atomic orbital is 3pz. This is before overlapping. After the overlapping, you get the structure more or less like this. This is the structure which you are going to get, and this is nothing but the sigma bond formation. This is the sigma cloud, which you can see here. This is a sigma cloud. Which is obtained. So therefore, finally, between hydrogen and chlorine, you find that there is a single bond. This single bond is nothing but the sigma bond. Single bond and sigma bond. So this is the type of overlap which we call it as sp overlap. So the next type of overlapping here is, that is third one, p2p overlapping. P2p overlapping. The best example for P2p overlapping is chlorine molecule followed by oxygen molecule followed by nitrogen molecule. So here, if you go for chlorine molecule, I can say that if you take chlorine molecule, you find that between two chlorine atoms there is a single bond. The single bond leads to a sigma bond formation. Between if you take oxygen molecule, between two oxygens there is a double bond. You find that one bond is pi and the bond is sigma. That means wherever you find that there is a double bond formation taking place because of the overlapping of atomic orbitals, once a double bond is formed, one bond is sigma bond and the other bond is pi bond. If you go for nitrogen molecule, as we already know, nitrogen molecule is always a triple bonded molecule. So between two atoms of nitrogen, you can find that there is a triple bond. The middle one is always the sigma bond, and the above and below bonds which are formed are called pi bonds. So that means just we have to prove that in the chlorine molecule, oxygen molecule and nitrogen molecule, in chlorine molecule between two chlorine atoms there is one single bond. That single bond is nothing but sigma bond. And in oxygen molecule between two oxygens there is a double bond. So you find that in the double bond we have one sigma bond and one pi bond. In nitrogen molecule between two atoms of nitrogen, you are finding that here the middle one is the sigma bond and the above and below bond are called pi bond. So we have to just prove that the sigma bonds and pi bonds in all these three molecules. So as already I told you, one thing what you have to note here is, during p2p overlapping, when p orbital to p orbital overlapping, occurs, what we have to identify here is, here two types of overlappings are taking place. One is end on end overlapping. It's also called along the internuclear axis, end on end overlapping along the internuclear axis. Here definitely the p2p overlapping results in the formation of sigma bond or sigma cloud. Another type of overlapping here is, that is sidewise or lateral. Sidewise or lateral overlap, which results in the formation of, that is, pi bond. which results in the formation of pi bond. So basing on this, now suppose for example you take chlorine molecule. If you take chlorine molecule, Cl2 molecule, in the Cl2 molecule, if you take one chlorine atom, atomic number is 17, the nearest noble gas configuration neon of 3s2, 3p, x2, 3p, y2 and 3p, z1. So you are finding that the 17th electron of chlorine is consisting of the 3pz atomic orbital and it contains one unpaired electron. So take two chlorine atoms there in the chlorine molecule. These two chlorine atoms, if you take the first chlorine atom has 3pz atomic orbital, that is the 17th electron is entering into the 3pz atomic orbital, and the 3pz atomic orbital is dumbbell shaped in its shape. So we have to take two chlorines. So for two chlorines we need two p atomic orbitals, that is 3pz atomic orbitals, both are dumbbell shaped. So directly I am going to draw a diagram for both the chlorine atoms of their valency shell orbital. This is valency electron orbital of the chlorine. Valence electron orbital of the chlorine is given by 3pz. So that's why here I am taking, this is chlorine, first chlorine in dumbbell shaped structure with its electron. The orbital is 3pz plus overlapping takes place. So again I am trying to take one more electron of the 3pz atomic orbital of the second chlorine also with its unpaired electron. Both of them they try to overlap. This is end on end overlapping. It's very clearly understood that the overlapping taking place is end on end overlapping. If it is end on end overlapping, this results in end on end overlapping, end on end overlapping, and that will result in the formation of a sigma cloud in this pattern. Here you can find one chlorine atom, here you can find one chlorine atom, and here one electron with a dot. This is sigma cloud. Sigma cloud is obtained. So this very clearly makes us to understand that the end on end overlapping of the p atomic orbitals along the internuclear axis between the two atoms always results in the formation of a sigma bond. But if the same overlapping is taking place sidewise or lateral overlap, if it is taking place, then I can show you that figure also here. Suppose if you take the same 3pz atomic orbitals of two chlorine atoms, this is sidewise or lateral overlap in chlorine molecule. So we can take two dumbbell shaped structures of chlorine, first chlorine, then electron, again second chlorine also dumbbell shaped structure with an electron. It can give you okay. This is the pi bond electron, this is pi cloud